Hello everyone, it's Wilson here. Today I want to talk about a more complicated problem about finding an equation of the plane. So as you can see here, we are given three planes right here. Two of those planes, they are going to intersect, and then we want the plane that will pass through that line of intersection of those two planes and also perpendicular to the third plane that we are given here. Okay, so how do we do this problem? We still just need to do a sketch to see what the situation looks like, and then we want to find the necessary information to write down the plane equation. And it's really important to just remember that we only need two things so that we can come up with the equation. One is the point, okay? Are we given a point? No, actually, we don't know the point, right? And then what about the normal vector? Do we know the normal vector of the plane that we're trying to determine here? We actually don't know that either. So that means we need to find both pieces of information. So first, let's just do a sketch here. And what happened is that I'm just going to use blue to show the stuff that are given to us. What happened is that we are given two planes and they're going to form a line intersection, right, by intersecting. So what happens is that, let me just draw a plane right here. Let's say we have a plane. Okay. So, and then the other plane. Okay, what happened is that those are the two planes that we have. And then the line of intersection is actually given by that, right? So this is the line of intersection of those two planes. Okay, what happens is that the plane that we are trying to determine here, okay, must contain this line of intersection. So what does that mean? That means let's say if the plane that we're trying to determine here looks like this, then it contains this line of intersection. Okay, so what do we want to find here? We want to find this one. Want to find this, right? We want to find an equation of this plane. But that's not the only pieces of information that's given to us. We also have we also have the plane that's perpendicular to the plane that we're trying to determine here. And again, I'm just going to use blue for that. And so you know what's going on. This one, okay, this one must be perpendicular to our plane. This plane that's in white. Okay, so what happens? Then we are going to just get another plane right here. Okay. And then, yes, so this one is also given, right? And this one is also given, and it's perpendicular, right? So, yeah, that doesn't look like it's perpendicular. Yeah, let me redraw that. Does this one look more perpendicular? I don't know, maybe like this. I think this looks better. Yeah, like this. Okay. So now, actually, this line intersection, I'm going to determine that. So that's not really given to us. So let me just put it in red. And so you can see that this line intersection is something that we gotta find here. Okay. And then the other thing that we need to find right here is actually what else do we need to find here? We need to find a point. And how do we get a point? It's actually quite easy. So all we need is that if once we find this line, then we can find a point that's lying on this line. And if there is a point that lies in this line and the plane contains this line right here, then we have a point that lies in the plane that we're trying to determine. Okay, so the point will be just any point that's lying there. So that's what we're also going to find here also, okay? And then what else do we need to find here? We need the normal vector of this plane right here. If we are to find the normal vector, as you can see, right? So how do we find this normal vector? This is also not given to us. And the way that we do it is this. So we need to find two vectors that's in this plane, right? And what happened is that we take the cross product of those two vectors and then we can find this normal vector. And then you may say, how do we find two vectors in there? We are not even given enough information. Well, actually we can. If you look at this perpendicular plane right here, we can already figure out one vector. It's really because what happens is that the normal vector of this given plane right here, right, this perpendicular plane, is that if you write down as normal vector, you can think of it as lying in the plane that we are trying to determine here. And so this V2 right here actually lies in the plane that we're trying to determine. So all we need is its normal vector. So that's quite easy, actually. We just read the coefficients, and then we can find the normal vector. Why do I label this as V2? Because we already have V1, but I did not put it down yet. It's really because, think about this. If we have a line, we actually can just come up with 2 points. Okay, so let's just put one more point on the line. What happened is that we can use those 2 points to form a vector. And that vector that we are getting here can be considered as a vector, well, that's a vector that lies in the plane that we are trying to find here. So we have the V1, and then we also have this V2. We take their cross product, we can find this normal vector. And then also we use one of the points to actually write down the answer. Is that okay? That's the whole idea. That's the big picture, right? And now the question is, how do we actually carry out all this calculation? Well, let's just do it step by step. Okay, so first thing, we want to find those 2 points, right? And then you may say, how do we find those 2 points? This is really just the same thing as solving a system of linear equations. We have 2 linear equations in 3 variables. That means we can, as long as it has at least one solution, that means we are going to have infinitely many solutions. In this case, as you can see, if those 2 planes intersect, they are going to intersect in a line, and the line contains infinitely many points, right? So we can find a lot of points. And then you may say, how do we do that? It's this. So actually, let me just put down the information here. I want to put down a template so that you can follow, right? So find the points. Then you may say, how do we find the points? It's this. We just substitute this z equals x minus 3y into this one right here. So if you just look at the system of 2 equations, 2x minus 4y plus z is equal to 6, and then the other one is z is equal to x minus 3y, right? So if you substitute the second equation into the first equation, then the first equation will give you 2x minus 4y plus, and then the z, right? What is the z? The z is actually x minus 3y, as you can see right here, is equal to 6. That okay? So I replace the z by the x minus 3y, and then I get this equation here. So let's simplify the equation. So if we simplify this equation, we are going to get 3x, okay? The 2x plus x, we get 3x, and then the negative 4y minus 3y, we get negative 7y. And that's equal to 6 right here. So now we get an equation, and all we need to do, remember, we actually have infinitely many choices, right? So all we need to do is to plug in some values for either x or y so that we can find the points. And it's actually a good idea to choose some values for y because this coefficient of x goes into the constant. So by choosing certain y values, it will make the calculation easier. So we can do this. We can let y be equal to 0. Okay, why do I let y be equal to 0? Then we are going to get the 3x equals 6, right? So then we have 3x is equal to 6. So that gives us x is equal to 2. Okay, and now all we need to do is to plug the x equals 2 and y equals 0 back into one of the original equations, and then we can find the z. So this one is easier because the z is already isolated on one side of the equation. So plug the 0 in here, plug the 2 in there, then we can figure out what the z looks like. The z is, in this case, would be what? if you put the 2 in here, 2 minus 3 times 0, so you just get 2. And so z is equal to 2. So our point, okay, so we actually got 1 point already. That means our point is what? It's 2, 0, and then 2. So that's one of the points that we have, right? X is 2, y is 0, and then z is 2, so we get this point. Now, we got to choose another y value to do this. If you choose y to be 1, then you are going to get minus 7 here, and then you move the 7 over, you get 13, and then you're going to have to work with fractions. So I recommend choosing y to be 3. Then you may say, why 3? Because you have a 3 here for this term. This is a multiple of 3, assuming that everything is in integer. So if you choose y to be 3, then this 7 times 3 is also a multiple of the 3. The 6 is a multiple of 3. So if we solve for x here, it will give us an integer instead of getting a fraction that's not an integer. Okay, so now what happens is that we have 3x is equal to, so if you plug the 3 in there, then you're going to get 21. Actually, I shouldn't put equal. I put minus 21 is equal to 6. So we are going to get 3x is equal to 27. So x is equal to 9, right? And then in that case, we can solve for z. So the z is equal to, what do we get for the z? So z is equal to, now let's plug them in. So we get the 9 here. We put the 3 here. So 9 minus 3 times 3, we get 0 for the z. So our second point is going to be what? 9, 3, and 0. So we get those 2 points. Now what's next? The next thing about finding the 2 points is to find the vector, right? So the vectors that lie in the plane. So we want to find v1. Now let's find v1. v1 is one of the vectors that lie in the plane that we're trying to determine here. How do we find that? We subtract the points, right? So that would actually not be difficult. Okay, so let's do that. Yeah, so simply the v1, right, is actually just equal to, let's just take this point, subtract the other point. So we are going to be getting 9 minus 2, and then 3 minus 0, and then we have what? 0 minus 2, so we are going to be getting 7, 3, and then negative 2. Is that okay? So we already get the v1, right? And then we also want to find the v2. The v2 is actually easy. v2 is actually the same thing as the normal vector, as the third plane that's given to us, right? The perpendicular plane. So right now we can just write down v2 by reading the coefficients. This equation here is 3, 1, and negative 1. So we get 3, 1, and negative 1. So we get that. And then right now, what's next? What's next is that we are going to just find the cross product of v1 and v2. That will give us the normal vector of the plane that we are trying to determine here. Is that okay? So let's do this. I may be running out of space, right? So just to move the things a little bit up so that I get more space. Okay, now let's continue. The normal vector, right? The vector normal to the plane. Actually, I would simply just put the n right here instead of writing down the words. So we are going to have the v1 and then cross the v2. And then we are going to get the vector. Well, actually, I can set up the determinant right here to make it easier for us, right? So that I have, let me just put it right here. So the I, we have the J, and then we have the K, right? So let's put down the vectors. We have 7, 3, negative 2, and then we have 3, 1, negative 1. Right? Yeah, So that would give you this normal vector right here. So let's just do it. So what do we have here? We cross out the row, we cross out the column, the first row, then we are going to get this here, right? So we get 3 times -1, we get -3. And then we have -1 times -2 minus -2, right? So +2. Okay, so we have that. And then now for the middle component, make sure that we put the minus sign in the front, right? So we would have to put the minus sign. And then here, so let's continue. We cross out the first row and then the second column. So we are going to get 7 times -1. We get -7. Okay. And then next, we subtract 3 times -2, subtract -6, adding 6. Okay, now continue. We cross out the first row, the third column, then we are going to get this 2 by 2 determinant. So we are going to get 7 times 1, we get 7. And then -3 times 3, we get -9. So we are getting -1, and then we have what? -1, -1, we get +1. Get +1 here. And then lastly, what do we get here? We get 7 minus 9, we get -2. That okay? So we have, this is our normal vector, and we have 2 points, right? So we are ready to actually write down the equation. Yeah, so let's actually write down the equation here, the plane equation. The plane that we want to find, right? So we need to write down this equation right here. How do we write down this final equation? Well, it's actually quite simple. We can use this point, maybe easier because the numbers are smaller. Okay, so we use that as the normal vector. So we are going to get minus, this is -1, right? So just leave that, and then x minus 2. And then this is +1, so just plus y minus 0, right? Because the y value for this point is 0. And then -2. And then z minus, what do we get here? This -2 comes from the normal vector, and then this 2 comes from the point, right? So I actually should highlight those points. As you can see, it's better that way, right? So that you know where those numbers come from. So with the minus, and then now I just highlight the point, which is 2 and then 0 here. And then we get the 0 here. Yeah. And then if you simplify this equation, then you can actually get equation in the more simpler form. So I'm not going to show that work here, but then you can just do the distribution, right? Distribute the minus sign and then combine like terms and then move the constant to the other side. And eventually you are going to get an equation that looks like this. -x, actually I don't need the arrow, -x plus y, okay? And then minus 2z is equal to -6. As you can see, this is +2, this is +4, so you're going to get +6 on the left side of the equation. Moving it to the right side, you get -6. Is that okay? So this is the final answer. This is the final answer. Is that okay? This whole idea, right? It's actually based on the picture that I'm drawing here. This is not an accurate picture, of course, right? But drawing the picture will actually help you figure out what to do, because when the problem gets complicated, we don't want to get lost in figuring out what we need to find here, or when we find something, what is that, right? So we need to figure out all those things, so we just cannot get lost in the whole process of finding stuff, and we shouldn't be doing it randomly either, right? So use this strategy when you're doing this kind of problem. Just make a sketch here. Doesn't matter whether it's accurate, right? If you draw it on GeoGebra, you can see that this is the graph that you're getting on GeoGebra is not really, doesn't even look the same as what I'm drawing here. But this would actually help us figure out the big picture. Is that okay? So that's it for this problem. To help make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. I want to work together with you to help students and children learn math more easily.